Hello friends, welcome to my channel Code Destination. So we are continuing this challenge one code one day, and like from previous several classes we are discussing different type of binary search related questions. So today we will also discuss, like in all the questions which we discussed already, in that like there was some hint or there was some sorting behavior written in the question, but today question it is not written. We have to we have to analyze that thing, how we can apply a binary search. So that is very important question as per interview perspective. So for today we are taking this problem number 1482, named minimum number of days to make a buckets. So what we mentioned in this problem, basically we have given the boom days. Like boom days, it means like it is given as an array, so it is representing that particular flower, uh, like this flower boom on the day 1 and this flower boom on the day 10. So like that it is given in the array, and we want to make a m bouquets. To make a bouquets you need to use k adjacent flower from the garden. It means suppose k is given 1, suppose k is given 2, so in that case we can also only make the bouquets with adjacent flower, like this one. So it should be adjacent if you want to make any bouquets, like that flower should be adjacent in that bouquet. So the garden consists of n flowers and ith flower with boom in the boom day, so it is mentioned here. And then can be used in the exactly one buckets, so like one flower can be used in the one buckets, it is also mentioned here. So in the example we can like see the input is given as a buckets, the number of size m is given. M represent like how many buckets we can make, and in that, like for one bucket how many flower we can take in that. So like for it is explaining here, so like for day 1, like if it is considered day 1, so on the day 1 we can only consider this flower, that's why we can only make the one bouquet. In the day 2, we can only make two bouquets, like this day 1 and day 2 only, because this is lie in the range. And on the day 3 we can make this flower 1, 3 and 2. So in this way, and like we have to make a 3 bouquet, and in one bouquet, the flower should be 1, so that's why we can make here 3 bouquet. In the second example, like it is mentioned, we have to make a 3 bouquet, and in e bouquets we have 2 flower. So in that case, like we can see, um, if you consider any days, 1, 2 and 3, so like till 3 we can only make the one bouquet, because the element is 3, and 1, 3, 2 is separated, so we can't make, because in one bouquet there should be adjacent element. So there are no adjacent element, like two adjacent element, like by the help of which we can make a bouquet, so there are no possibility, so I am returning -1. And in this case we are making the two bouquets with the minimum 3 uh, number of flowers. So like in this case we can make like at the day 7 we can make this, like this 3 or this 3. Okay, this is first bouquet. In the second bouquet we can make this 2 only. Okay, but it is not possible, because there should be minimum 3 flowers. So in this case we can make a 2 bouquet, but one is size of 3 and one is size of 2, and we can't take this one because this is not adjacent, this should be adjacent. So there are two possibility, either we can make bouquet with this 3 1, this 3 1, so they are one bouquet. And either we can make this, but we can't make this bouquet of 3 size, that's why we can't make a 2 bouquet, the like in which the flower number of flower is 3. So we consider 12 day. In the 12 day we can see, like we can make bouquet with this 3 and with this 3 adjacent, if you are taking the adjacent flowers. So after the day 12 it is possible, so that's why it is referring to day 12. And in output we are returning the day, like on which day we can make the number of bouquets 3 with the one bouquet is having this number of flower. So let me take an example so that we can like do the proper analysis of this. So like I am taking this example. So for this example, let me go through how it is, like we are making the bouquet. So there are two bouquet we have to make basically, and each bouquet have minimum flower 3. So let me draw this, like suppose bouquet, I have one bouquet and I have two bouquet, and in each bouquet the minimum like flower should be, not minimum, exactly flower should be three. So I put the flower three here, and here put our flower three. So I can consider day wise approach. So like it is obvious, like suppose I start day one. So in day one we can't consider any flower, right? Because we consider the flower when it's lie in that day. So like from this area whatever element is minimum, from that day only we can consider flower. So from day one, day two, day three till day seven, like there are no flower till day seven. So that's why we can't consider any flower in that, and we can't make any bouquet. But from day 8 we can see the minimum element of from this array is day 8. So from day 8 we can consider this flower, this flower, this flower, this flower, and this flower. So we can consider which indexes flower. Maybe I can write indexes here: 0, 1, 2, 3, 4, 5, 6, 7. Why I am writing indexes? Because like in a question mentioned that we can take only the adjacent indexes to make a flower like bouquet. So in the date what we can consider, we can consider 0, 1 index, 2 index value, 3 index value, and we can take 7 index value. So how many bouquet with this we can make? Like as a question it is mentioned that only the adjacent element I can take, and with the three size. So like either I can take these three size or these three size. Okay, so like on the day 8 we can make total like one bouquet we can make. So maybe I can write here yeah. So at this point at the date basically we can make this either, like we can in the one bouquet we can consider only like three flower. So I can consider this three flower or this three flower which is adjacent, but I can't consider this flower. Why? Because this is not adjacent. This two three is adjacent, but the seven is not adjacent flower. Okay, so we can't basically consider that. So in that case we can't make like total two bouquet, like M is defined here. We have to make a two bouquet. So at day 8 we can't make a two bouquet. It is only one which is less than our two bouquet, like which is M here. Okay, on then after that like I will move for further days. So from day 9, there are no element because 9 is not considering here. Day 10 is not. So 9 to 10 there are no flower I can choose, but day 10, day 10, day 11, day 11 I can choose one flower from here, this one. So what indexes I can choose? Basically 0, 1, 2, 3, and this is 5 and 7. Okay, so with this I can also how many bouquet I can make? Either I can take this 3 one or this 3 one, but in this case also I can't check, like I can't choose any three size bouquet. I can choose this this is adjacent, like 5 7 is like sorry 5 7 is also not adjacent, so we can't choose this one. Or we also can't choose like that, like 0 1 2 or 2 3 5, because it is mentioned here question each time, like in each bouquet we can make a one flower. So like in this case I suppose I choose 0 1 2 and 2 3 5. So in that case this flower, this two flower is duplicate, like it is present in the different bouquet. So also we can't make. So in this case also we can only make one bouquet. So one is also less than two. So we have to move like other days, like we have to move after that. So at day 12 I will choose, like on day 12 what flower I can choose? I can choose this one as well. So in this way which indexes I can choose? 0 1 2 3, okay, and 5 6 and 7. So at day 12 we can see like either we can choose this one or this one. Okay, because only one we can choose, because if you choose both then we can't choose, because in that case in both bouquets like the common flower will come, so which is not possible. But there are possibility that we can either choose this or this. Okay, so there are one bucket I can make, and this is also addition 5 6 7, so I can make two bucket here. So in this way I can make two bucket. So here I can make two bucket, which is our required, which is m value. So basically after day 12 I can make two bucket, which is required in the question, and each bucket considering a minimum three element, because I can see here each bucket considering three elements. Suppose in this case I am considering this three one only, and in the second bucket I am considering this adjacent value. So like after day 12 this is possible to make two bucket, which is like each bucket is having minimum three flower in that. So in this case our answer will be day 12, like 12 will our answer. So basically this is the approach what we are going to follow, and with this approach first we will implement our code, like in code how we can apply this approach in the logic, and after that we will optimize that logic, like how we can optimize that logic. So in between we will discuss how we can optimize using binary search. Okay, first let me approach this brute force. So what we are doing basically for each days, we are iterating from day wise. So from day 1 to day 12, and so for that we are iterating day wise. So we can define the range, like from which minimum days, which maximum days I can iterate. So it is sure that whatever the value in that area is minimum, from that we can start only, because before that, suppose this minimum date is minimum date day is 8, and here maximum date is 13. So if you start from 0 to 7, like unnecessary, so in that there are no flower we can choose, so there are no need to start from here. Or we can start like from like after that 13, so there are no flower from 13, so only we have to iterate at this range. So we are just considering this range, like including this one and this one. So from minimum to max we are only iterating for days, min to max. So first we have to find this min to max days. Okay, so for that let me write one separate function which will find the min to max, like min value and max value. So it will return the array find min max day. Okay, so in that I will pass my integer bloom day. Okay, sorry, bloom day I will pass. Okay, so from this bloom day I will find the min and max value. So I just refine my min as a bloom day 0 value. Okay, and my max day I will define my bloom day 0, and I will just iterate in the whole array bloom day array, and I just find my min day and max day. So how can find math dot min, I will find the min day, and in max I will store my max day. So it will give the min and max, and after that I will return the array, like first element will be min day and second element is max day. So this I write this function to like get the min and max. So here I will get my min max day first. So min max day I will found first. So here I will get my min max day. Okay, in that I have to pass my bloom days. So I will pass my this array, and it will return my min and max state. So from this min, like min to max, I have to iterate basically. So maybe I can write this min day, min day is stored at the 0 index, which I return, and my max day I will write. So it is 1 index. So I just found my range, like from min day to max day I can iterate and find the bloom, like what is total buckets I can make. So this is the first thing which I like find here. So this first thing, what find min day and max day, min and max day. So we can sure that we are iterating from min to max. And secondly, what we are doing, for every day we are calculating this box codes. So how we are calculating, like for day 8 we are just considering all the element, like 1 2 3 4, like till here first we consider all the element like for day 8, and we just check like in each box like box codes we can like include 3 flower. So basically I will divide by 3, so we can like find how many box codes we can make with these flowers. And whenever it break, I just only start from again, like here from break, so I will start again from here. Like with this 2 we can't make any box code, so it will return 0. So in this case, like we can make only one box code. So in this way I will just write the function which will return, like we'll pass this our bloom day and this k value, and which will return the how many box codes we can make. Like we are considering this box code and we are iterating till our box code is not equal to our required box code. So I will make a function which will like give how many box codes I can make using the bloom days. Okay, so here I can make like box codes. So I can write the function public static int to return the how many box codes I make. So box codes for that particular day I will find. Okay, so what I have to pass here, I will pass my suppose bloom day array. So let me define as an array only, and for day, particular day, which day I have to find, and this k value. Okay, k value because in the particular box code how many maximum, like how many flower can we take, so we have to pass that one as well. So how we can basically get my box code? So initially my box code is 0 and my range is like array dot length in which I iterate, and I will just take a temp value. I will explain why I am taking. So let me loop first from I is equal to 0 to n in like whole array. In bloom array I will iterate. Okay, and like I will just check if my this array like bloom day value ith value is less than equal to that day. So in that case I will just like count. Maybe I can take the count here. I will just plus, I will increase my count, like that flower I can take, and that is adjacent. Why I am doing this, like from here I am iterating, like for this 8 case I am considering. So for 8, like it is maybe here some 9 or anything. So if it is greater, like equal to or greater than, define, like this is given the day 9 8. So in that case I have to just increase my count, and this count will store this, in this case 4 value. And after that what I have to do, so once it is break, like that count is not, like that day is greater than less than the array value. In that case we got our one box code. So in that case I have to add in my box codes, like how many box codes I can make. So what I have to do, total count divided by k, because in each box code there, like the c represent total number of flowers, and this k represent in like in one box code how many maximum flower I can take. So if I divide that, so I can get the box code number of box codes. So count by k, it will return the number of box codes, and after that after that the count will be 0. Why I am making 0 here, because suppose I consider this 4 8. So for this, with this row I can make one box code, but once it break I can't make, because we have to consider only the adjacent element in the question is mentioned. So here I have to just reset my count value so that it may start from 0 again for again making the box codes for adjacent flower. So I will just, in the else condition, I will just reset my count variable, and at the last in the box codes I have to add whatever remaining flower, if like at the last any remaining flower remains, so that we can add like how many box codes I can make, and in that case after that I will return my box codes. So this function I write for getting the total number of box codes for the particular day, and in each box court if it is taking the k number of flowers. So just iterating, and we are counting the each adjacent flowers, and if it is break, so I'm just adding how many box I can make which previous flower, and then again resetting the total number of count of flower. And at the last, why I did that, suppose at the last there are some like this condition hold and it is not like coming in the else condition. Suppose um, there are suppose area element less than is day, so there are three element in count, and after that like we just ignore that, like what in which case it can happen I can show you. Like there are given case, suppose 8 8 8, in that case I have given this array only, and like case size is 3. So in that case this condition hold, and in my count there will be 3, and it will not go in the else condition because this is not break, so like it is condition hold. And at the last, if I will not add this, so in the box it will return 0, but in real scenario like we have to return c by k. So for this, considering for this case I just like use this extra add. So this function will return total number of box. So after that, what I have to do, for each day I will loop from min to max day. So from min day and till max day I will iterate. Okay, so and for each day, like here for each day we are calculating the box. So for each day I will calculate the box. So for considering that box, what I have to do, okay, so here I will take total count of box. So and this function is returning total number of box here. So I will just call this function with this value bloom day. I will pass my array, and which day I have to check, so that I will pass day and k value. So it will calculate the total count of box. And here I just consider that like once for particular day I got my total number of box like 2, which is equal to, then in that case I have to return. So basically what I can do, I can check here if my total count of box equal to required box, which is m here. So in that case I have to return that day, so I will return that day, and if it doesn't found, so I have to return -1. So like as I discussed already the logic, same I am doing, I just iterating from minimum day to maximum day. Okay, like the 13, and in between whenever we found like total number of box which I have to make is equal to that required box which is required for according to question, we have to return that day. So let me run it first. Yeah, so it is giving some error, array dot length. Okay, here I have to pass array because this is my bloom days. Okay, so it is running, and in that case one test case is failing here for this one. Okay, let me check why it is failing first. So for now I think your logic is clear, so maybe I can just clean that. And yeah, so for this test case why it is failing, let me explain you first. So it is checking like this, suppose I'm not taking that much value, maybe I can take only 2 value like 8 8, but yeah, and m value is 1. So like in this case m value is 1, and in one box I can make one flower. Okay, so why it is failing, like first what we have to do, for day 8 I will iterate because my mean day start from 8. So for 8 how many box I can make, so 0 1. So for day 1 I can consider, sorry, for day 8 I can consider 0 or 1, and in one box I can take maximum 1, like one flower. So with this I can make total number of 2 box. So it is returning 2 backward here and here. In this case, total count of backward, and 2 is equal to check, it is checking here. So 2 is equal to not equal to m, so it is returning like -1 in this case. It means we can't make a this backward with this k, in which like each backward is having one flower, but it is not true, right? Because in question it is mentioned that if we can make that minimum, like basically it's mentioned, it is find the minimum number of days to make a backward. Okay, so like in first day we can make a like total backward 2, correct, which is greater than total required backward. It means we can make, correct. It is not it is not saying that exactly that number of m backward we have to make. It is saying we can make or not. So if we can make backward greater than m, in that case also it is true, so we have to just return that backward like that day. So instead of checking equal to case, maybe I can check greater than or equal to. In that case we have to just return the minimum days, and days start from minimum to max. So it is obvious that if any minimum days we can make greater than m backwards, it means we can make backward that number of backward that particular day. So that's why we are returning day. So maybe I can run now. So yeah, this test is also passing. Let me submit it. Yeah, so it is running. Yeah, so it is giving time limit exceeded. It means the time, like the algorithm which we write, it is taking the large time. So how we can optimize that? Let me think how we can optimize that one. So what we are doing here, basically, let me draw in the number line, because in binary search generally we draw on the number line, correct? So what we are doing here, from day min to max, min to day max. Okay, we are like, what we are doing from day min to max, we are just finding the backwards, total number of backwards we can make. So here, so we are finding the number of backwards. Suppose here min to max, we are how many backwards we can make. So for that, maybe I can just show you here. Just want to print the total count of backwards. Print total count of backwards. So let me run it, and yeah, so like in this case one, like maybe I can take a better example for that. Yeah, so for this case one, sorry, case 3, we can see it is returning this like total number of backwards, like each days from min to max. Like in this case from 7 to 12 there are 6 elements, so from 7 day we can make it like one backward. For 8 day we can make one backward. For 9, 10, 11, and for 12 we can make two backward. So what it is doing, like it is giving all, like from this day minimum to max, how many total backward I can make for each day. So like we can make this backward, this backward, this backward. Okay, so every day we are calculating the backward, and we are just in that total days, like in that total backward number of backwards, we are finding the minimum days, like minimum day on which we can make total number of backward greater than required, like m. So here our target is to find m backwards we can make or not that particular day. So suppose for particular day I considering this point here at this index. So suppose for this day, suppose this is day I. Okay, so for day I can make backwards. Suppose day I can make backwards, which is suppose number of backwards n, or I can take b. So total backward I can make b, and that at day I we can make a backward greater than, okay, and day I whatever backward I can make, like suppose b, which is greater than sorry, that is less than, or I'm considering less than total required backward. So what it is representing, let me observe for that. So for like particular ith day I can make the backward which is less than the required backward. It means we have to shift this day after. Why? When we shift the days, our days, it means we can consider the more walkouts in that condition. Like if you are at till ith day, we are making how many walkout b, so we are making the less walkout which is required. So basically we have to shift we have to increase my days, so we have to shift this side. But suppose at day uh, I am making any b number of walkouts which is less than sorry greater than m. Okay, not less, greater than. First I take the greater than equal to m. Okay, so in that case what I have to do, suppose in the particular day I am making the m number of walkout, but then question we are mentioned, it is required that we have to find the minimum number of days. So in that case also we have to shift left side. Okay, suppose there are one day here on jth, so I can take on jth day I am making the b walkouts which is which is equal to m. So we will find, is it possible to make this number of walkout in the less days, like suppose here any condition. So I will find the left side. So we have two condition, like how we can move left or right. Like in general we do binary search. So like what it is doing, like in from min to max day we are just calculating the walkout, and we are checking with the target value. If we are getting the target value walkout, so in that case we are returning. So it is type of linear. We can see here from day to min to max we are just calculating the walkouts, and if our total number of walkouts is greater than or equal to m, so we are returning that. So it is a linear search. So can we do like this search using the binary way? Why we can think in the binary way? Because the total number of walkout we are making, that is increasing. We can see here that is increasing, because it is obvious that if it is like some walkout we are making at the day I, like if some walkout we are making at the day I, so that is definitely less than whatever walkouts we are making I plus 1. It is get less than or equal to, it is always sure. So it means our total number of walkouts what we are considering at this line, it is in the increasing manner. Correct? It means our data is sorted. So there are sorting behavior. As I already said, binary search is not applied only the like if this anything like any data structure which contain the sorted data directly. But sometimes we have to think whether that contain the sorted behavior. Like in this case, whatever walkouts we are calculating, that is sorting in the range, like from day min to max. So here we can apply the binary search. Okay, because for day I, if we are making any walkouts, so that will be definitely less than the walkout we are making day I plus 1, I plus 1 day. In this way it will be less if I am making day I plus 2th day. Because if we are shifting the day, so in that case basically we are ranging like we are expanding our days. Or if we are expanding our day, we can calculate like we can get a more walkout. In this case here, like for day 1 we can take only this one walkout, but for day 2 we can calculate 2, but for day 3 we can take this day 3, like 3 walkout, 1 3 and 2. So in this way either it will be constant, either we can make only one walkout, or it will increase, it will not decrease anywhere. So this walkout, our total count of walkout is increasing, and we know our range, and we know our target, like this m value. So in this case we can apply binary search definitely here. So for that what we can do, like I already discussed the binary search in the previous class. So if you didn't watch, please watch that. So maybe I can use that same code which I write for binary search here. So I will just write this here, and I will pass my range. So maybe I can take a start and end, and I will just initialize with my start and end days. So this is simple binary search, and it will I just use that binary search to finding this, because this previously it was taking the linear operation. So I will check my answer, and I will search using the binary. This search method is using the binary search. In that case I will pass my bloom days first. So I will pass my bloom days here, Okay. uh, okay, I will pass my bloom days. Yeah, that is fine. And then after that I will pass what in the search operation. Basically I have to pass my range. So first I will pass my target, because I think in the search we are getting the target. So what is our target in our case? We are finding this total number of barcodes we can make or not. And what is the range? So our range is min day to max day. So I will just pass my min day and max day. So in this case it will return the day, minimum day, and I will just like shift, like I will just write logic according to our case. So what we are doing basically, for min day to max day, our lower bound, higher bound, and in general like in binary search we do like find the minimum, middle point. And for that middle point we just calculate, in our case for every middle, like for every day we are calculating the bloom day. So I will just call that bloom for day function for calculating the total number of barcodes I can make. So I will pass this one, and in that I will pass my this bloom day array. And what I have to pass, total number of barcodes I have to make, and each barcode containing how many flowers. So it will return the total number of barcodes for particular day, like this m day I can make. And according to that I have to set my condition. So what I write here, if my number of barcode which I can make particular day is um, less than the target, like target is here total m number of barcodes. So if it is less than the target, so it means I have to shift my like range to the right side. So I have just shift my middle day to the right side, as I explain here and the number line. If my total number of barcode is less than this m, so it means we have to set my day range. So I will just shift my this previously I told I is here, j is here, this is min or max day. So I will set my min day after that, because we are finding now in this range. Because if it is like from this ith value we can't find the required target, so in the less day we can't find, so we can ignore this totally, all the indices before that. We will just shift right side. But in the else condition, what will be happen if my bloom day is equal to or greater than target? So in that case what I have to do, I will just take that as an answer first. Like at that day I can make um, at particular day I can make total number of bloom, total number of boycotts which is required, like number of target here, basically that it is equal to m. So that can be our answer, but we will find the answer in the left side as well. Why I am doing this, let me show you. As I explained here already, if particular day I can find like at the day j, like for this particular day I can make total number of backward m, okay, which is correct, but we have to minimize this. So for that I have to shift my boundary left side. Whether there are some possibility like in less day we can find same backward, like in the less, if we in the less day we can find same barcode, so that is the minimum day. Okay, in that case I am just shifting. If it is either equal to or greater than, we have to shift my like right boundary to the left. So it is in the else condition, and if it is not, then we have to return the -1 here, or not, sorry, I have to return my answer, because in the answer we are storing my days. So for that maybe I can take here answer, and answer will initialize as a -1, because if there are no possibilities, so it will return the -1. So in this way we can run, and here basically my m is as a target, so I can just replace to the target. Maybe I can run now. Let's see whether it is working, what it is doing. K variable is not defined. Okay, I can pass k, because total in each bucket how many max flower I can take, I have to pass that one as well. Okay, so let me see whether it is running now or not. So it is failing for the some test cases. So let me see why it is failing. So what we are doing here, like it is taking this one and minimum three Bouquet we have to make, and each Bouquet is containing one. So first we are finding the min max, which is correct, and for min to max we are iterating, and we have to search. Okay, so in the min to max day we are passing in our target value also we are passing correctly, and this k also all pass correctly. So in search maybe I can see whether we are doing something wrong, and in the left boundary my start and end it is correct, and in the answer we are defining this. So for every we are calculating our middle day first. For middle we are searching, and we are finding bloom day for particular day, like we are passing number of days and target value. Okay, that is also correct. No, but here like for bloom day we are not passing k, actually for particular day one which we are searching. So on m day we are searching, correct? So we have to pass here m, so that was wrong. So let okay, let me, oh sorry, I am returning actually -1 here, my mistake. I have to return answer, whatever answer we are getting, correct? So I think that was a mistake. Yeah, that's why I was thinking like a logic is correct, but why it is not running. Yeah, so let me submit it again. So yeah, we can see it is taking 70 millisecond and beats 80% of the users. So like I hope you understood that logic what we did. Like first we define how we can apply binary search here. So for day we just define the range first. So from min day to max day I define my range. In binary search the range required from which day to which day we can move, and like here from previous logic we are just like iterating a linear manner. So in that case I just iterate the binary manner. So I just find the middle value, and for middle value I just check for that day how many how many Bouquets I can make. If I can make less Bouquets, so it means I have to shift, like I have to set my days. So after like I can ignore all these days. If this like on this day I can make a less Bouquet, so it means in the previous day I can definitely make the less Bouquet. So I will shift at that side. So I just shift my I minimum day to after that, like minimum day start from here, and this j maximum day is here. So I will shift this is in this range, and if it is greater than, or like if it is my like day I is equal to, yeah, greater than m. So if it is equal to case, so in that case also we have to shift a left side, because maybe in previous days, like in less days, we can find the same number of Bouquets. So it is good because we have to minimize that number of days. So yeah, I hope you understood the logic, and in that logic we are iterating, like finding the max mean, which is big O of like n operation, sorry, n operation. So it is a big O of n time complexity, and this is search operation. So it is also like we are search in a search operation. What we are doing basically for each day we are finding, so it is a log n operation, because for min to max, suppose I am taking min is the first index, and right, so the most case that mean and max range, like we are finding the mean and max from the bloom days. So we can see here like array value is 10 to the power 9, and it is n value is 10 to the power 5. So basically this search operation is what it is doing, from min to max it is finding that. So okay, what we are doing here, number of I from min to max we are finding from low to high. Okay, and for every like low to high case we are just finding the bloom for day, and bloom for day operation is taking how many time, an operation. So basically this search method is taking, like this operation is taking log n, because we know binary search take log n time, but for every iteration we are iterating n times. So basically it is n into log n operation. So n into log n operation it is. So if I add this total iteration n plus here I can write n plus n into log n. So we can take like n into log n is greater than n. So at the last we can see total operation, like total big O of n log n operation it is. So it is solution taking big O of n log n operation, and previously whatever solution we did, that was taking n square, because for every element we were just using the like linear search in that case, so it was n square operation, but this operation is n log n, so it is more optimized. And I hope you understood the logic, how we build the logic, and how we think whether we can apply here binary search or not. Because if you see the code directly here, maybe I can show you in the previous submission, it is given time limit exceed. So what we was doing here, we are just finding the Bouquet in the linear manner, but I just optimize this function linear to binary, that's it. So how we can search in the binary manner, so that's it, that is improving our time complexity. So I hope you understood the logic and intuition, and how I can code and connect with the logic. So thank you for watching my video.